Hi Year 4, hope you're all okay. Welcome to Thursday's math lesson on fractions. But before we go into fractions, can you please have a look at the starter? If you don't feel that confident with perimeter or area, then have a go at the blue one. If you feel really confident, then go straight onto the purple one, okay? Or just do both, it's up to you, I completely don't mind, okay? So have a go at one of them or both, and then come back to me afterwards and we'll go through the answer. So press pause, have a go, and then come back to me so we can go through it together. Okay, hopefully you managed to have a go at some of those questions. I'll go through the blue one first. So we had to find out the area. So remember, to find out the area, you have to count the squares, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it's 17. Now, each square is 1 centimetre squared, therefore it's 17 centimetres squared because you've got to have the measurement on the end, okay? On the purple one, we'll do 1, 2, 3, 4, 5, 6, 7. Now we've got halves here, but remember, one half of a square and another half of a square will add to make one square, okay? So we've already got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so already we've got 8 here. Now, before I count any more, I just want you to have a look. Have a look at the shape past this red line. Ooh, didn't mean to do that. And the shape before this red line. What do you notice about them? In fact, they're the exact same. Okay, it's symmetry. Apart from this middle box, they are the exact same. So you know that the area of this part is 8. So what could you do? Rather than counting this again, what could you do to make it easier for yourself to work out the area of it? So hopefully you managed to work out that you've just times it by 2, because if this is 8, then times it by 2 and it would be 16. But then also we have this middle one, so you will still have to add that on. And we will count it just to check, okay? Because it's fine if you want to still count the squares, because you still get the right answer. So we have 8 here, 9, 10, 11, 12, 13, 14, 15, 16. And then remember the half ones go together to make 1, so that'd be 17. Okay, so it is still the right answer, but that was just a kind of a quick way for you to see how else you could have done it. All right, so let's move on then to today's learning intention. Now, as I mentioned, we are moving on to fractions. Now, I'm sure a lot of you are thinking, oh, I don't like fractions. There's a big thing about fractions. It's not just with children, with adults as well. A lot of people don't like them, okay? But that's fine. We're going to work our way through it, and we're going to try and get rid of this fear of fractions, okay? Because fractions are fun, okay? And we're going to have fun with them as much as we can anyway. And if you're ever in a pickle with it and you really don't get it, you know where I am. I'm on Teams pretty much all day. And I'm always at the end of an email if your parents want to email me, okay? And I can help you as much as I can, because they are tricky, but actually if you break it up and go through it step by step, then we can get through it, okay? So we'll work on it together. Do not fear fractions, all right? So our star words today then, we have numerator, fraction, equal, equivalent, and denominator. So fractions you've been looking at since year 2, I would have thought, so you should know what a fraction looks like, but we will go into that in a minute. Numerator and denominator, we're going to go into that in the next slide, so I won't tell you what that is just yet. Equal and equivalent. Now these kind of mean the same thing, they're just different words. If something's equivalent to something else, it means it's equal, okay? So it's just a different way of saying it. Equivalent looks like a big fancy word, but it just means it's either the same or it's equal, okay? And today we're looking at equivalent fractions, so we're looking at different fractions which have the same value, okay? Let's have a look at this then. So just to get those brain juices flowing, let's have a look at this. So we have a rectangle which is split into 4 sections, 3 of which are shaded. So what fraction of the shape is shaded? So we have 4 boxes altogether, and then we have 3 shaded. Therefore, the fraction of the shape shaded is 3/4, okay? Because 3 out of the possible 4 boxes are shaded, okay? Now, the denominator is the bottom number, okay? And the numerator is the top number. Now, one way I like to remember it by is the D in denominator I think D for down. So then I know it's at the bottom, it's down, okay? I don't know if that will work for you, but it works for me, and I just thought I'd let you know in case it does help you. So denominator's down, D for down, it's the number at the bottom, numerator is on top, okay? So now we've just quickly recapped what a fraction looks like. Let's have a look at this. So which representation of 4/5 are correct? Look at the picture, discuss with a partner. Now, you might not have a partner at school, sorry, at home. If you're in school watching this, then you will have a partner. But see if you can have a think or discuss with a parent or someone at home and see if you can give a reason for your answer. So which representations of 4/5 are incorrect? Explain how you know. So pause the video, have a look, give yourself a couple minutes and have a think about each one. Okay, hopefully you managed to have a little look at all of the representations. We're going to go through them together now, so if you weren't able to do it, then hopefully this will make a bit more sense to you. So the first one, this one here, is a 1, 2, 3, 4, 5, yeah, a pentagon, and it's been split into 5 sections. So we have 5 sections altogether, and we have 1, 2, 3, 4 parts shaded. Therefore, that is a representation of a 4/5 because they're split up equally into the triangles, and therefore there are 4/5 of the shape shaded. Okay, this one here obviously is correct because that is 4/5. That's how you write a fraction, and that is correct. Okay, so we know that that one's good. The dogs. Now, this one would be incorrect because actually we have 5 dogs here. Now, depending on which type of dog you're looking at, we either have 2 white ones, so 2/5 of the dogs are white, or we have 3/5 brown, and neither one of those show 4/5. So therefore, this is incorrect because depending on how you look at it, it doesn't show 4/5 anyway. Okay, because if you're looking at the white dogs, 2 out of 5 are white, or if you're looking at the brown ones, 3 out of 5 are white. Brown, sorry. Let's have a look at this one then, the one at the bottom. So we have 1, 2, 3, 4 purple counters and 1 yellow counter. So if you're looking at the purple counters, this could be 4/5 because there are 5 counters altogether. So 5 is your denominator, and 4 of those are purple. So therefore, that could be a representation of 4/5. However, if you're looking at the yellow ones, it would be 1 out of 5. So it'd have to be if you were looking at the purple counters, because there are 4 purple counters out of a possible 5. Okay, and this one. So this one we have 1, 2, 3, 4, 5 boxes. Brilliant. So we have 5, and then we have 1, 2, 3, 4 shaded. Great. So we have 4/5 there as well. Now, hopefully, some of you are thinking, no, that's not right, Miss Flukes. And it isn't. Now, why do you think actually that doesn't show a correct representation of 4/5? Have a look at each of the rectangles. What's different about them? What's the same about them? And hopefully you've had a look and thought, they're not the same size. Therefore, they can't be a fraction of that number because you can see this box on the end is huge. So that's taken up a lot more than this box. So therefore, it's not a correct representation of 4/5. Whereas the one up here with the pentagon, they're all equal size. Okay, so with fractions, it always has to be divided up equally. Okay, same with the one on this thing, on this slide. Sorry, we had 4 boxes and they were all of equal shape. Okay, so the shapes always have to be equal, or else it's not a correct representation. Okay, just something to keep in mind. Let's have a look at this one then. So always, sometimes, or never. Alex says, if I split a shape into 4 parts, I have split it into quarters. Explain your answer. So pause the video. If you have someone to talk to at home or in school, then do that. If not, then think about it on your own. Is she correct? Is it always correct, sometimes, or never? So read the statement again if you need to and have a think about it for me. Okay, welcome back. Hopefully you had a quick think about that or a chat with someone. So if I split a shape into 4 parts, I split into 4 quarters. Okay, let's give it a go then. Let's draw a shape. I'm going to draw a square and I'm going to split it into 4 parts. So there's one part. There's another part. Actually, I'm just going to move that there. So we have 1, 2. I'll draw one more line. 3, 4. Okay, so I've split a square into 4 parts. Does this show quarters? Think about what I said with this question here. Does this show, have I split it into quarters, do you think? Now the answer would be no, because actually these are not the same size. You can see that, let me just get my pen, this part of the shape is a lot bigger to this, so therefore they're not equal and they wouldn't be quarters. Okay, they're split into 4 parts, yeah, but they're not quarters. They need to be split into 4 equal parts if it's going to be quarters. So let's try again. If I draw this shape, now this is split into 4 equal parts, therefore this would be split into quarters. Okay, so her statement is sometimes true. It's not always, it's not never, it's sometimes, because you can see here is not true, but here it is. It just means that you have to split it into 4 equal parts. Let's have a look at this then. Now this you can try at home if you want to. It's just a way of seeing equivalent fractions. So what you need to do is use 2 strips of equal size paper. You're going to fold one strip into quarters and the other into 8. So you'll fold up into 4 sections and the other one into 8s. Then you'll place the quarters on top of the 8s and lift up 1 quarter. How many 8s can you see? And then you'll just have a look at those questions. Now, there's a lot there, so don't worry if you don't want to do it, because I've drawn, well, I've had the same representations here, okay? So at the bottom here, you can see I've got, let me look for a pen a minute. So this one, we have 1/2, because there are 2 boxes, 1, 2, okay, and they've been split into halves. So these are both 1/2. What about the top one? What has the top one been split into? It's split into 4, hasn't it? Okay. Now, each section would be worth a quarter. Sorry, this is really messy. I should not have attempted using my pen. Let me just rub out the horrible line I have in the middle. That might make it a bit easier. Sorry about this, my friends. It's a lot more difficult on a computer than on the board. Okay, so can you see that this big shape is the same as this big shape? It's just been split into 4 parts and 2 parts, okay? Now, can you see that this line here matches up? So therefore, this quarter and this quarter are the same as this half. They take up the same space, okay? So they are equivalent, all right? They are the same. So actually, if you add 1 and 1/4, you would get 2 quarters. So therefore, 2 quarters is the same as a half, all right? We'll try it again on this side. So now I'm going to split the bottom one into quarters again. All right, so we've got 1/4, 2/4, 3/4, 4/4. And now I'm going to split the top one. Oh no, I didn't mean to do that. Sorry about this, my friends. Split it into 2 again. And then I'm also going to split these up. I'm doing it this way, so then they're all going to be equal, all right? There we go. So now I have, let me get my pen. I have 1/4 on the bottom, so each section is worth a quarter. And on the top, what is each section worth? Have a count of how many there are and see if you can work it out before I write it. So it's 1/8, okay? There are 8 sections, 1, 2, 3, 4, 5, 6, 7, 8, all right? So each section is worth 1/8, okay? So now using this, you can see that 1/4 is the same as 2/8. Can you see it matches up? That section of the quarter is the same size as 2/8, all right? So they are equivalent. Equally, you can see that this part is the same. So 2/4 would be the same as 1, 2, 3, 4 eighths. Okay, so 2/4, I'm just adding them together. 2/4 is the equivalent to 1, 2, 3, 4 eighths. All right, that's all I'm doing, just adding them up. Okay, if you want to go through that again, because that's quite a lot of information, then feel free. If not, I'm going to show you something even better. So this, my friends, is called a fraction wall. You might have seen one before. If not, here is a fraction wall. They are very pretty, and you might think, oh, there's a lot of fractions, but they're the most useful thing you might ever see during your fraction topic. Okay, so it basically shows you one big shape, which is split into 12 parts because we go up to the fraction of 12ths, and we have at the top one whole, and then it's split into two. So this one whole is split into two, therefore we have 1/2, 1/2. This whole is then split into three, so we have 1/3, 1/3, 1/3. This whole rectangle is then split into quarters, into 4 parts. We have 1/4, 1/4, 1/4, 1/4, and so on. And as you can see, it goes down and down and down. And where the lines match up, so if I just get myself one of these, where the lines match up, so you can see here, this line goes through quite a few of the fractions, which means they are equivalent. So 1/2, I can see, matches up with 2/4. It also matches up with 1, 2, 3, 6. It also matches up with 1, 2, 3, 4 eighths and 1, 2, 3, 4, 5 tenths. Okay, so you can see that that matches up there. Let's find any other ones that match up. So if we have, okay, I found another one. Let me get my line ready. So we can see here where it has 2, 6. So we have 1, 2, 6. This matches up with this line down here on the ninths. So then how many ninths are equivalent to 2, 6? It would be 3 ninths. Okay, and if you also spotted, it's equivalent to up here to 1/3. Okay, so this is really helpful because it just shows you all the equivalent fractions up to 12, and it is a really useful tool. This will be on Teams and on the website if you want to print it off or if you want to use it separately. Okay, but I highly suggest using it. All right, so time to do some questions then, because I have been waffling on for quite a long time in this lesson. So this is group 1. If you're not very confident in fractions, just start on group 1. There's nothing wrong with that, and see how far you get and just go from there, because it doesn't matter too much. Just spend about 20 minutes doing them, a bit less maybe because I spent a lot of time talking today, and just see how you get on. So this is group 1. This is the second question for group 1. So if you want to just pause the video when you're ready to do it and then go through it. Sorry, I forgot to say with this one, I know it says to shade an equivalent fraction to the fraction given. So if you haven't got access to a printer and you don't want to print it off, that's fine. Just draw it in your book, or just write how many you would shade. Okay, so you don't actually have to shade it if you don't want to, or if you, in your books, you can draw lines in between the lines in your book, if that makes sense, to make your own fraction bars. Okay, so that was also group 1. And then this is group 2. I'll make this a bit smaller so you can pause the video. There you go. So again with this, you would have to draw the strips, okay? Now, in your book, don't worry too much if it's not equal, okay? As long as I can see you've got the idea of it, then that's fine. This is group 2 as well. Sorry, again, it's too big. There we go. And then this is the challenge. So it's a reflect question today. So you are going to have to write how a fraction wall shows equivalent fractions. That's what we've just talked about in the video. All right. So those are your questions. Once you're ready, come back to go through the answers. So if you want to take about 15 to 20 minutes doing some of the questions, and then come back to me and we'll go through the answers to your questions. I'll see you in a bit. Okay, welcome back. Hopefully you had a good go at some of those questions and you didn't get yourself too confused. we're going to go through the answer together now. So if you were in a bit of a pickle, hopefully this should help. So the first one, shade an equivalent fraction to the fraction given. Write down the equivalent fraction. So this one, you can see that 2/3 have been shaded, 1/3, 1/3. So then that is equivalent to 1, 2, 3, 4, 6. Okay, because you can see that the line matches up there, so it needs to be the same amount. All right. This one we have 1, 2, 3, 4, 5, 6, 6, 8. Sorry, so that should be 6 and 8. And then look at what these are divided into. It's into 4, isn't it? So each one of these would be worth a quarter. And you can see straight away that the line comes there. So if you add them up, 1, 2, 3, it would be 3/4. So 3/4 is equivalent to 6/8. All right. This one is a bit trickier because you have to do 3. So the first one is divided up in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 1, 2, 3, 4, 5 shaded. So it was 5/10 shaded in the first one. The next one is divided into 1, 2, 3, 4, 5, 6, 7, 8. And we have 1, 2, 3, 4 shaded. I'll shade them in for you. And then this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one's divided into 12s. And we have 1, 2, 3, 4, 5, 6 shaded until we get to that point. And I'm not going to write them in there because it'll be too small and messy, but 5/10 is equivalent to 4/8, and that's equivalent to 6/12. So these are all worth the same, okay? That's the whole point in it. They're equivalent. They're all the same, all right? Let's look at this one then. So you had to say whether these were equivalent or not. So I'm just going to put a tick or a cross whether they are, just because it's easier. So 5/8 is equal to 1/2. So you had to find 8s, so, and then count along 5. 1, 2, 3, 4, 5. Okay, now a half would be up here, all right? So therefore it's not equal because it goes past that line. 3/6 is equal to 3/9. So 6s, 1, 2, 3. So it's that line again is equivalent to 3/9. 1, 2, 3. So those aren't equivalent because the lines don't match up. So that is a cross as well. 4/8 is equivalent to 1/4. So we have 1, 2. I just rub off what I've done because it's going to get a bit confusing else. 4/8, 1, 2, 3, 4 is equal to 1/4. So that is definitely not equal because 4/8 is a lot bigger, takes up a lot more room than 1/4. That is not right as well. 4/6 then is equal to 6/9. So 4/6 is 1, 2, 3, 4 is equal to 6/9. 1, 2, 3, 4, 5, 6. And there we go. We have an equivalent one because it takes up the same amount of space in your bar. Okay, so therefore that is equal. And then we have 4/4 is equal to 9/9. So we have 1, 2, 3, 4. So that would be 4/4 at the very end because it's a whole. And 9/9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. For some of you, you might have recognised that straight away 4/4 is actually the same as a whole, or just one, because that's a complete shape or shaded shape, the same as 9/9 would be a whole. So some of you would know straight away that they are equal. All right. Let's have a look at group 2 then. So use a fractional strip to show that these statements are true. So you have to shade them in. So 1/3, you have to colour in 1 is equal to 3/9. And if you wanted to label them as well, you could have done. I'm not going to do that because it would take me too long, and it will just be a right mess. So each one of these would have been 1/9. 2/5 is equal to 4/10. So you should have circled, shaded in 2 out of the 5, and then 4 out of these 10. So these show 1/5 each, and these show a 10th each. And then the last one, 1/4. So these show a quarter. These show an 1/8. So we have 2/8. And then the last one is 3/12. So each of these are a 12th. Okay, I will write that down, sorry, because that will probably be really helpful for you. And that was 1/5. I'm just showing you what one little box is in each one, okay, just so it's clear for you. This one was 1/8 and then the last one's 1/12. And you can see as the denominator gets bigger, the boxes get smaller, okay? Let's have a look at this one then. Lee says that he has shown the same fraction as Zach because they have both covered in 3 sections. Do you agree? Explain how you know. So this one, you can see that the shape itself, the shape they've used is the same size, and he split it into 1, 2, 3, 4. So he split it into 4 and he shaded 3. So he shaded 3/4. This one, so Zach has used 1, 2, 3, 4, 5, 6, 7, 8. So he split the shape up into 8 equal parts and 3 are shaded. Now we know that 3/4 is not equivalent to 3/8, and you could use your fraction rule to work that out. But also, if you put this underneath, if you drew it underneath this, you would see that this line would come about here, wouldn't it? So it doesn't come anywhere near how much of this is taken up, okay? So you know because you can see that it's smaller, or you use a fraction rule to help you work it out. All right, and then finally the challenge, explain how a fraction rule shows equivalent fractions. You might have written a variety of things for this really, but it shows it because it has kind of like a rectangle for each one, like a bar, and each time it is sectioned into either 2 parts, then 3 parts, and it shows equivalent fractions because it is consistently the same shape. Sorry, it's quite hard to explain actually thinking about it. So each one is divided up into their fraction, and then you can see how much of that shape is taken up, okay? I'm sorry if I've not explained that very well. Maybe I'll come back to that in tomorrow's lesson, just to revisit it, because I've probably not explained it very well. All right, I'm hoping that that was all okay for you. I know fractions are quite tricky and they can take a while to get used to, but we'll work on it and we will get there in the end. All right, so good work today, my friends, and I won't see you, but I'll speak to you all tomorrow for tomorrow's lesson. Bye.